Every distributed system is secretly speaking its own language.
JSON,
Protobuf,
Avro,
RPC, event streams.
And the moment those languages evolve incorrectly, microservices stop understanding each other. Data silently corrupts, queues fail, deployments turn into outages. This is the invisible layer holding modern systems together.
Section 1. The illusion of schemaless.
Let's shatter the myth of the schemaless architecture right now. Formats like JSON and XML, they give us this nice illusion of total flexibility. But let's be real, they're bloated and completely riddled with edge cases. Take JSON, for example. It literally doesn't distinguish between integers and floating point numbers. It doesn't specify precision. That is a nightmare at scale. I mean, remember when Twitter actually had to send their 64-bit tweet IDs twice through their API, once as a number and once as a string, just to stop JavaScript from silently mangling the data? So yeah, human-readable formats are super easy to start with, but they become a massive liability the second you're dealing with complex data flows.
To actually survive at scale, you need schema evolution. And I am not just talking about a nice-to-have best practice here. This is a mathematical guarantee of forward and backward compatibility. When you are pushing zero downtime rolling upgrades across a cluster, your new code absolutely must be able to read old data. And your old code? It cannot crash when it encounters new data written by updated services. It is literally the only way to avoid the catastrophic outages we talked about at the top of this explainer.
Section 2. The binary heavyweights.
So, you move beyond JSON, you hit the terabyte scale, and suddenly you enter the arena of the binary heavyweights. Let's look at how these actually work under the hood. Take message pack. It's essentially a binary variant of JSON. It compresses our example user record down to 66 bytes. Definitely better than plain text. But fundamentally, it's still flawed for massive scale. Why? Because it still wastes valuable bytes transmitting the actual string field names, like username and favorite number, over the wire every single time. In a distributed system, that is a ton of wasted bandwidth.
Now let's step up to protocol buffers and Thrift and see how they solve this. They cut that exact same payload in half, down to just 33 or 34 bytes. How? By completely ripping out those repetitive string field names. Instead, they replace them with immutable, hard-coded field tags. Think of these tags as tiny binary numbers acting as pointers. They act as the structural DNA between the reader and the writer. The encoded data never even whispers the field names again. It's incredibly compact and blazingly fast.
Section 3. The Avro paradigm. But that raises a pretty huge question. What if you have a colossal relational database dump? We're talking hundreds of tables, and you absolutely do not want to manually map thousands of field tags by hand. Enter Apache Avro. This format operates on a completely different paradigm. It achieves an ultra-lean 32-byte payload by dropping field tags entirely. You heard that right, no field names and no tags anywhere in the payload. Instead, it relies purely on the exact strict order of data types defined in the schema. You just stream the bytes in sequence, and the schema tells you exactly what data type comes next.
Okay, so the obvious question is, how does Avro handle evolution if everything is locked to a strict order? It actually performs a brilliant magic trick at runtime. The Avro library takes the schema that wrote the data, the writer's schema, and places it side by side with the reader's schema. It instantly resolves the delta. If the writer sent a field the reader doesn't know about, Avro just ignores it. If the reader expects a new field the old writer didn't provide, Avro seamlessly drops in a default value. Compatibility is maintained flawlessly, without a single field tag.
And because it relies on field names in the schema rather than hard-coded numerical tags in the data, Avro is the undisputed king for dynamically generating schemas directly from relational database tables. Every single time your database schema changes, boom, you just auto-generate a new Avro schema. You never, ever have to sweat an admin accidentally colliding field tags again.
Section 4. 3 highways of data flow. All right, now that we have our encoded data securely locked down, we have to route it. In modern architectures, data fundamentally flows across 3 high-stakes highways. First, databases, which, if you think about it, is really just asynchronous storage where you're sending messages to your future self. Second, REST and RPC, your synchronous, immediate service calls between clients and servers. And third, message passing systems and brokers for true, decoupled, asynchronous scaling. Let's zoom in on that database highway first. This is where a strict schema evolution allows a single database to seamlessly serve records written across 5 different historical schema versions, all as if they were perfectly uniform. Your application code,
It has no idea that a specific row was written 3 years ago in some legacy format. The database and the encoding logic handle the entire translation seamlessly, on the fly.
Now, what's incredibly interesting about the RPC highway is the deployment order. Because backend servers generally update way before the clients that call them, your schema evolution strictly dictates your rules of engagement. Requests sent to the server have to be backward compatible because that new server needs to understand older clients. Meanwhile, the responses sent back must be forward compatible, so the old client can actually process the new server's response without crashing. It is a very delicate dance.
And finally, the asynchronous message passing highway. Brokers like Kafka push millions of operations per second by appending immutable, binary encoded events to partitioned logs. The absolute genius here is the decoupling. It completely untangles the producer's schema from the consumer's timeline. The producer is just rapidly blasting data in, and multiple independent consumer groups can read that data sequentially at their own pace, totally oblivious to the system that created it.
So I want you to look at your own architecture right now and ask yourself a serious question. Are your microservices actually decoupled? Or are they just tightly bound by fragile, undocumented schemas, meaning you are exactly one undocumented JSON change away from a total system collapse? Understanding this invisible language of encoding and evolution isn't just some micro-optimization. It is the bedrock foundation of system reliability.